On October 20th, 2025, Amazon Web Services, AWS, the backbone of a significant portion of the modern internet, suffered a massive service disruption in its U.S. East 1 region, shaking the digital ecosystem and highlighting systemic risks inherent in centralized cloud infrastructure. Beginning at 3:10 a.m. Eastern Time, the outage affected core AWS services including EC2, S3, DynamoDB, Route 53, CloudFront, and Lambda. While AWS quickly clarified that this was not a cyber attack, the incident exposed vulnerabilities in monitoring and auto-recovery systems, demonstrating that even the world's leading cloud provider is not immune to cascading failures. The impact rippled across the globe, touching social media platforms, financial services, gaming, AI applications, and airlines. From Snap and Meta to PayPal, Robinhood, and Delta Airlines, the outage left millions of users temporarily unable to access services. Digital commerce, content delivery, and financial transactions slowed or froze, generating economic repercussions estimated in the billions. Analysts and investors were forced to reassess risk exposure to highly concentrated cloud infrastructure, while regulators and enterprise IT leaders considered strategies to mitigate single point of failure risks. This outage exemplifies the fragility of modern digital systems that, while highly efficient, are increasingly interdependent. It raises questions about redundancy, cross-region failover, multi-cloud adoption, and the trade-offs between centralized scale and systemic resilience. AWS's U.S. East 1 region, being its first and largest, supports critical infrastructure for global operations, which is why even a minor DNS or load balancing failure can cascade into worldwide disruption. The incident also underscores the human and technical dimensions of cloud operations. As automation grows in complexity, monitoring modules, load balancers, DNS routing, and auto-recovery loops, errors in any subsystem can propagate unpredictably. The outage serves as both a wake-up call for companies reliant on AWS and a stress test for investors, regulators, and engineers seeking to maintain trust in cloud-based digital infrastructure. In the early hours of October 20th, AWS's US EAST 1 region experienced a severe outage that disabled key services for hours. Core systems including EC2, S3, DynamoDB, Route 53, CloudFront, and Lambda were affected. The US East 1 region is AWS's oldest and most critical, hosting an extraordinary number of enterprise workloads and public-facing applications. While Amazon quickly confirmed that no cyber attack occurred, the problem originated from a DNS monitoring failure, which created a load imbalance across data centers. This triggered a cascading effect as auto-recovery mechanisms misinterpreted system status, leading to service disruptions across multiple global services. The effects were immediate and widespread. Social media platforms such as Snap and Meta experienced outages. Gaming networks like Epic Games and PlayStation Network went offline. Financial services, including Coinbase, Robinhood, and PayPal, faced operational interruptions. Airlines like Delta and United Airlines reported disrupted check-in processes, while digital commerce platforms experienced temporary halts in transaction processing. The incident essentially froze parts of the internet, revealing how dependent global infrastructure has become on a single cloud region. Speaker notes emphasize the scale and immediacy of the outage. Highlight that US East 1 is critical due to historical growth and centralization. Explain the DNS and monitoring failure as the root cause, stressing the chain reaction that led to widespread disruption. Point out global implications and the interconnectedness of digital services. The economic and operational impact of the AWS outage was extensive. Businesses ranging from social media platforms to gaming companies and financial institutions faced direct service interruptions. For example, Snap users could not send or receive messages. PayPal and Venmo users were unable to complete transactions. Airlines encountered disrupted check-in processes, delaying flights. Catchpoint analysts estimated that the total economic loss from the outage could reach billions of dollars, reflecting downtime costs, lost productivity, and customer dissatisfaction. For users, the outage served as a stark reminder of how dependent daily life and business operations have become on cloud providers. The inability to access services for several hours disrupted work, communication, and commerce across multiple continents. Even as AWS technicians worked to restore functionality, many services continued to face slow response times, queue backlogs, and system errors. The failure highlighted the risk of relying heavily on a single cloud provider or region without robust multi-region or multi-cloud failover strategies. Speaker notes stress the real-world consequences on businesses and users. Highlight the diversity of affected industries: social media, finance, airlines, gaming. Note potential economic losses. Explain that outages like this underscore the importance of contingency planning and redundancy for enterprises relying on cloud infrastructure. AWS's US East 1 region outage originated from a DNS resolution failure. Misrouted traffic caused load balancers to direct requests improperly, leading to cascading failures in DynamoDB and caching layers. Monitoring modules, overloaded by the misrouted traffic, entered an auto-recovery loop that compounded the problem. This meant applications believed their backends were down, displaying error messages or system maintenance pages despite physical servers operating normally. The incident underscores the systemic risk of centralized cloud infrastructure. While centralization allows for scale and efficiency, it introduces vulnerabilities where a failure in one subsystem can propagate across millions of dependent applications. Highly automated recovery systems can exacerbate problems if monitoring data is inaccurate or misinterpreted. AWS's experience illustrates the delicate balance between automation, scale, and resilience. Speaker notes: break down the technical root causes: DNS failure, load imbalance, monitoring overload, auto-recovery misfires. Explain why these cascading failures occurred. Highlight the lesson: centralization is efficient, but increases systemic vulnerability. Use real-world analogies, e.g., digital earthquake, to make the concept relatable. AWS represents approximately 31% of the global cloud market and constitutes a significant portion of Amazon's profits. The outage not only impacts operational stability for customers, but also has financial implications. Companies may accelerate multi-cloud adoption, cross-region failover, and disaster recovery strategies to mitigate the risk of future outages. Competitors like Microsoft Azure and Google Cloud Platform may gain reputational advantage, capitalizing on perceived AWS vulnerabilities. For investors, Amazon stock faces potential short-term volatility. Analysts may question whether centralized regions expose Amazon to concentrated operational risks, possibly affecting guidance and long-term profitability. Additionally, regulators may consider mandates requiring multi-vendor infrastructure for critical systems to reduce systemic risks in sectors like finance, healthcare, and transportation. Speaker notes emphasize market share and financial importance of AWS. Discuss potential investor and competitor implications. Highlight regulatory attention and enterprise response. How companies may diversify cloud infrastructure to reduce systemic exposure. The outage shook confidence in cloud stability. AWS has long sold reliability and scalability as core value propositions. Yet the US East 1 disruption illustrates that complexity itself can be the enemy of reliability. Experts describe the event as a digital earthquake, emphasizing how interconnected cloud systems propagate failure globally. Businesses and investors may reevaluate reliance on single regions, review service-level agreements, SLAs, and strengthen disaster recovery and redundancy protocols. While no malicious activity was involved, the failure calls attention to the fragility of modern digital infrastructure, the limits of automated monitoring, and the need for robust multi-region strategies. The incident may serve as a catalyst for systemic change in cloud adoption and risk management practices across industries. Speaker notes: highlight loss of trust and reputational impact. Discuss systemic lessons: reliance on centralization, multi-region strategies, disaster recovery, and SLA reassessments. Stress that this outage is both a cautionary tale and a potential turning point for enterprise cloud strategy.